All right, well, welcome back. So in this section, we're actually going to be introducing two really important concepts that are going to be super influential for both mathematicians as well as computer scientists. And that's going to be this notion of divisibility as well as congruence. So we're actually going to start this conversation looking into this notion of divisibility, which is actually just a topic that you see kind of back when you first start doing long division, whenever you do that kind of back in elementary school or something like that. Once we have this kind of foundational idea about what divisibility is, we're going to use that information to slowly introduce this notion of congruence. What ends up happening is that when you start looking at divisibility properties, you're ultimately going to have things that don't divide nicely. In that situation, you end up having some non-zero remainder. What ends up happening is that I want to start lumping things together that have the same remainders into a bin. What's going to happen is that these things that happen to have similar remainders are going to behave very similarly. And what's going to happen is that that whole notion of kind of lumping all of these things together is going to be a super important concept that ends up kind of building up this notion of modular arithmetic. And this notion of modular arithmetic is actually kind of what's underlying most of computer science, at least from the kind of early coding side of things. You get these really nice error checks and all of this other really good stuff coming out of this notion. So to start this thing off, we're going to, like I mentioned, kind of reintroduce this idea of divisibility, kind of bringing us way back to elementary school or whenever you first start introducing this notion of divisible. What we're going to be doing in this case is looking at this idea of trying to divide by 11. And in this case, we're going to be looking at a collection of different things. And the question is always going to be the same. I want to see which of these numbers are going to be divisible by 11. Well, the easiest way to look at this is just to simply try to take these numbers, so in this case 77, and try to divide by 11. What's going to happen is that you're going to see some really nice things emerge. What's going to happen is that 11 goes into 77. It looks like 7 times because 7 times 11 is in fact going to be 77, and you end up getting a remainder of 0. What I want to do next is actually kind of represent this a slightly different way than you may be used to seeing these things. Normally you would write this as, 77 divided by 11 is equal to 7. What I want to start thinking about is actually seeing this structure of what 77 looks like. How does 77 play with both 11 and 7? So in this case, I'm going to say that 77 is going to be this number 11 multiplied by 7. And that 7 is indicating how many times at 11 goes into 77. In this case, I have my 11, which is my divisor, and that 7 is going to be my quotient, this kind of remaining bit after I do this division. So in this case, if you're not kind of used to seeing this kind of nice representation, this is going to be what's going to underlie the actual formal definition of what it means to be divisible. And that's what we want to lead towards, is kind of this nice example of practicing various divisibility things to slowly lead into this slightly more formal structure. So next up, let's look at the number, 4,334, and let's switch colors in this case. Let's look at doing this in purple. What's going to happen is that this number 11 is going to go into this 4, 3, 3, 4, and I want to see how many times is this going to occur. 11 goes into 43 3 times, and I'm going to pick up a 33, and then start subtracting a 1, a 0, a 3, and a 4. 11 is going to go into 103 probably 9 times in this case because it's going to introduce a 99. And then what ends up happening? I get a 4, and then a 4 as well. And now you can see that this is going to work out really nicely because a 4 times 11 is a 44, and I'm going to pick up a remainder of 0. So in this case, this is going to work as well. And the nice thing that actually occurs is that I can get this nice factorization of this number 4,334 again. In this case, what I see is 4,334 is still going to equal this divisor, this 11, multiplied by that new quotient, which in this case is a 394. All right, let's do maybe 2 more of these things just to see kind of what's happening. Next up, let's do the negative one just because sometimes people forget about how to divide some negative things. So in this case, if I want to determine whether or not negative 132 is actually divisible by 11, the way that I like to do these things is just do everything in the positive world, and then once you're done with that, reintroduce that negative sign. So 11 goes into 13 once, 1 and 11. All right, that's going to give me a 2 and a 2, and that's going to introduce a 2 as well, giving me a 22 and ultimately a remainder of 0. What you want to be careful then in this case is if I try to represent negative 132, what it's going to be is it's going to be an 11 multiplied by a negative 12. I got to bring in that negative sign somewhere, and in this case it's going to come into the world of this quotient. So in this case the 11 is my divisor, and that negative 12 is my quotient. Okay, so let's look at something that's actually not going to divide nicely, and that's actually going to be this 4, 5, 6, 3, 1. 4, 5, 6, 3, 1. In this case, 11 is going to try to go into this thing. So 11 goes into 45, in this case 4 times. I'm going to pick up a 45, a 1, 6, 3, 1. 11 goes into 16 once. The 1 and the 11 is going to make an 11. In this case, I'm going to get a 5, a 3, and a 1. What's going to happen is that 11 goes into 53 4 times, picking up a 44. And then what's going to be left at the end of the day here is going to be a 9 and a 1. 11 goes into 91, I guess 8 times to introduce the 88. And then at the end of the day, you can see that I'm going to have a non-zero remainder in this case. I end up with a remainder of 3. So what's going to happen is that we're going to, at some point in time, introduce what's referred to as a division algorithm. And what that's going to kick out is it's going to kick out this idea that this number 45631 can be represented as this divisor, this 11, multiplied by this quotient, which is a 4148. And then there's going to be plus this little remainder that occurs afterwards. So in this case, this is my divisor, this is my quotient, and that little 3 is actually going to be my remainder. The existence of this remainder is going to say that this thing is not divisible by 11, because what I should be seeing is all of these little 0 remainders. In this case, what's happening is that I'm having this little plus 0 in all of those situations. So in all of those cases, I actually get these things to be nice and divisible. In this situation where I have a remainder of 3, that notion of divisibility actually breaks down. So the last one, that's just kind of while we're on the topic, let's just dive into this idea of 0. The question is, does 0 have this nice divisor of 11? Does it play nicely with it? In this case, if I start to think about all of these things are of the form, I'm going to have n, the initial number, multiplied by 11 times some q in this case. I want to see, can I fill in the blanks with a 0? So 0 is going to be 11 multiplied by some number. In this case, yeah, the idea works out pretty nice. So just put 0 in there. So in this case, 0 is equal to 11 times 0. The idea is that 0 divided by 11 is 0. And so that little 0, that quotient, is just going to go right there. So in that case, the 0 does work. I'm out of room, but if you would test, you would actually see that this 2,728 also is divisible by 11. So just as kind of a side curiosity, there is a little bit of fun fact about how we can determine whether or not something is divisible by 11. And once we get full-fledged into the world of induction and things like that, we're going to start to look at a few of these kind of silly little divisibility properties. And the 11 one actually has kind of a cutesy little test. So the idea is, if you start to look at all of these little numbers that make up these kind of bigger numbers, in this case, just looking at 77 as a 7 and a 7, those kind of placeholders, what happens is that if you subtract those two things, you get a 0. If you look at the number, let's say in this case 4334, if you look at this alternating sum of those terms, so in this case it's going to be a 4 minus 3 plus 3 minus 4, you see that it kicks out a 0 as well. Also, if you look at the number 132, if I represent that as a 1 minus 3 plus 2, so in this case, I'm picking up all of those numbers and I'm just introducing the kind of alternating plus minus as we go. So in this case, 1 minus 3 plus 2. In that case, you can see that it kicks out a 0. And in all of those three cases, I did have that this thing was going to be divisible. So you can kind of start to see this pattern emerging. Well, the interesting thing is that when you look at the number 45631, and if you do this alternating sign, so 4 minus 5 plus 6 minus 3 plus 1, it kicks out that 3. And in this case, that's going to be something that is not 0. And in that case, that's actually going to be this test on whether or not this thing is actually going to be divisible by 11. There is one small little caveat that ends up occurring in this case. If you look at the number 2728, what happens when you do this alternating sign thing, you're going to get a 2 minus 7 plus 2 minus 8, and it actually kicks out a negative 11. But if you look at it, negative 11 is actually going to be divisible by 11. So that's actually the formal test, is that if you look at one of these numbers, you construct this kind of giant alternating sum. If the thing you get at the end of the day is actually divisible by 11, the original number you started with is in fact divisible by 11. And like I said, later in the course when we actually start talking about some of this induction and things like that, we'll be looking at a whole bunch of these kind of cutesy little divisibility tests. All right, so let's go ahead and actually dive into this slightly more formal structure about what this notion of divisibility is actually all about. It's actually the point of why we initially started this kind of full-fledged kind of gross representation of looking at the number 77 as actually an 11 times 7, likewise looking at this number of 4,334, representing this thing as an 11 times 394. In all of those cases, I would say that the number 11 divides whatever that initial number that we started with. And in this case, that's exactly what this definition is going to say. The idea is that you're going to give me two numbers, in this case, call one of them n and call one of them m. I'm going to say that m divides an integer n. So in this case, what's going to happen is that I have the number 11 divides the number 4,334, provided that there's going to be some nice integer q, in this case this nice quotient, such that n is going to equal m times q. And in this case, you can see that I don't have that remainder term afterwards. It's going to be this nice perfect notion of divisibility. In this case, you're going to have n equals m times q. So in this case, we have those examples that we were just looking at. We have 11 actually divides 4,334. Since I know that 4,334 is viewed as my 11 multiplied by this random quotient that ends up occurring. Likewise, I have the notion that 12 is going to divide 9,876. Since I know that if I take 9,876 and if I divide that thing by a 12, I'm going to get a quotient of 823, and in that case, I don't have a remainder. In this case, you could also say negative 7 divides 84. Since I know that if I take 84 and divide it by negative 7, it's going to kick out a negative 12. So in this case, 84 is going to equal negative 7 times negative 12. All of these things are going to have this really nice form. There is none of this little plus r stuff occurring afterwards. The little plus r is going to occur in what's referred to as this division algorithm. The idea that sometimes this division isn't so nice and you end up having something else actually occur in this case. But for now, this notion of divides is going to be this perfect idea that everything kind of works out nicely in this case. It's a little bit of weird kind of notation and kind of some terminology. Initially, we have this notion of is something divisible by 11, and that's going to be you start with your bigger number and you say it's divisible by this smaller number. So in this case, 4,334 is divisible by 11, whereas in this case, we're going to introduce this notion of divides, which says that smaller number, that 11, divides a bigger integer, in this case, this 4,334. So it's going to go into that thing nicely in this case.